Hey guys, welcome back to our restoration project. So today we're going to take on our alternator, try and breathe some fresh new life back into it, bring it back to more of a show condition, and also we're going to take it apart and see exactly what's inside and what makes these work. Basically, it's a real simple component. It's easy to rebuild internally if you understand how they work. This particular alternator has an external regulator, so even more simple for us to work on. Visually, it looks a little bit weathered, but it's actually in pretty good shape. Not very rusted. I pulled one screw out here. You can see it has some surface rust on there, but aside from that, it's actually withstood the test of time fairly well. Also, the only other identification I have on this is going to be this remanufacturing label by Bosch. So it was remanufactured approximately 40 years ago by Bosch company, which is good. So it should be a fairly good quality components internally. And up to that, that's about all I know about this alternator. So let's go ahead and get it taken apart and see what it looks like inside. Okay, let's get this thing apart here. So I'm just taking off some of the insulators to keep them dry and clean before we soak our screws with KB88. And taking pictures of assembly order as we dismantle. And I'm using a Klein number 10 screwdriver, extra long for torque. There she is. Our brush is down in there. Look to be pretty good. We'll look at those closer when we get them out of there. Well, let me get this all cleaned up and then we'll take a look at it on the bench. Okay, let's take a look and see what we got here. And just a little disclaimer here, guys. I'm just trying to get through this part here of the car and just share some of the information with you. I am definitely no expert on alternators and all their components. I have just a basic general understanding of how they work and their components. And some alternators are much different in their makeup than this one. So for Porsche, we don't have an external fan here. It's probably utilizing the fan that's on the front of the fan housing to cool this one, although some alternators would have a fan in the front of here. So this piece here is just the front of our housing. It's going to bolt up to the front of our rotor and front bearing there. And then this guy here is our main housing. And this would be called a rectifier, and diodes here and underneath here. And so this piece here is called our rotor. This is going to be our front bearing, which is in really good shape. It's nice and tight. And I can feel the grease is slightly dry in there, but nothing crunchy. The back bearing here, perfect condition. We'll try and lubricate that one also. This particular piece here would be called a slip ring, and all these are pressed on to the shaft of our rotor. So I'm going to try and service this piece without pulling any of this off of here and repressing it on, because I don't have the tools and equipment to get everything to exact tolerances, so we really don't want to disturb those if we can. But the condition of our slip ring is almost perfect condition. If you had grooves in here and it was really worn, then you would need to replace this. But it looks like this is the original, and it may have been turned just one time, so we still have plenty of life left on that guy. And then our brushes. So we don't have an internal regulator. If we did have an internal regulator on this alternator, the regulator would most likely be part of this main board here. Here's our hardware, some pretty basic stuff. All our main leads will be insulated. This is all insulating parts here. And our long bolts, you notice they're not electroplated. I think that these will be like an extra hard tensile strength on that because of the length. So if you had like say a grade 5 here and you tried to torque these down, they would probably twist and break. So they probably use extra hardened steel for this, and that's why they don't have any kind of a zinc plating on there. And then looking at the back side of our main housing, so this is going to be called the Stator, and actually looks like it's in pretty good condition. Got some light surface rust on there. The back area here, this is where the rear bearing sits, and that has a couple of shims to keep tension on that rear bearing. So based on the overall condition of our alternators, we take it apart here, I can see there probably is no issues here that we really need to worry about as far as charging the system. So if you have a problem with your alternator, the problem is most likely in this unit right here. So you've got your brushes, which are carbon, and they are like a soft composite material that'll wear down against your copper slip ring here. And so once those wear down and they travel out, you'll reach the end of the travel right here where it reaches up against your slip ring. And once you no longer have any distance here to keep pressure onto the slip ring, you'll begin to get space in there. Once you start to get space in there, it'll start to arc and burn, and you'll lose your power right there, and you'll no longer have charging. Okay, and then moving on to our rotor. So what I've done is I've just taken the outside area and run it over our grinder wire wheel and cleaned up the surface rust. This particular unit is a single winding unit, so being very careful not to get any solvents or any kind of cleaning solution down inside. So we're just brushing it and then blowing it out with compressed air. Then we need to service our bearings, so I pulled the sealing caps off using a really small screwdriver. So really something small to kind of pry those guys off of there. You can gain access to the inside. And our grates in there is really kind of old and grungy. I just want to get it out of there. Best way to do that really is with a brush and gasoline, followed up by carburetor cleaner to rinse out everything under high pressure, and then let it air dry. After that, we'll repack and close it back up. Okay, so our bearings look pretty good now. I got all that gunk out of there, front and rear. So now what we want to do is pack them, and I'm using Mobil 1 synthetic. Typically I like to use a petroleum-based grease for packing bearings, but this is a electrically conducting device, so just for my own peace of mind, I'm using something that is not petroleum-based. Not that you would have any issues there, but we just don't want to take any chances on an old classic car. Squish it in there. Okay, that looks pretty good. So I think we'll just put our seals back in place now and clean it up. Okay, and then the next thing we probably ought to talk about here before we start putting this back together is diodes and what might be wrong with them. So on our trio board here, I've done the test, and this particular diode is not working. So what that means is a diode is basically a check valve for electrical current, so it allows electricity to go one way but doesn't allow it to come back the other way. So if it's flowing in both directions, this diode is bad. Or if you have a blockage, it won't allow it to come from either direction, the diode is bad. So it should read OL with your leads in one set of terminals, and it should have a digital reading when you switch them around. So let's just take a look and see what that looks like. So this one here, alright, so I'm getting a reading of 290. And I'm getting a reading of 3.5. Should be reading OL. So here, I'm reading OL, which means no current is flowing that direction. And here, 7.795, and here 0.985. Oh well, so these two are working and somewhat within range, but we're going to go ahead and replace that with a new board because we're able to get one. And then let's look at our new board just for the sake of comparison. We got OL, OL, and OL. Switch them around. And we get a fairly consistent reading. And then looking at our main diode, so I've already tested these, and they all seem to be somewhat working. They're not perfect like I'd like to have them. Let's just check and see what's going on with them. Oh well. Oh well. And oh well. We switch it around. A little bit of paint on there. And then this one here. Oh well. Oh well. Oh well. You can see this one here is a little bit weak on its reading. So let's have a quick look at some new parts and find out where I got them for this old alternator. So I found this place online called Maniac Electric Motors, and really an awesome website, very, very helpful with reference numbers and old alternator parts, starter motor parts, and man, it just doesn't matter what you have. These guys can pretty much find whatever you're looking for, and customer service really, really good there. So I was able to get a new replacement stator, not expensive, only like around $60 for this, so let's go ahead and go with that. A new trio diode board, not expensive there either, and then also able to get some new brushes. So we'll just unsolder and resolder that lead and install our new brushes in there. And we didn't need a slip ring or bearing, so we're going to go ahead and use the ones we got. But yeah, if you guys are looking for some electrical parts, I highly recommend Maniac Electric Motors. And having a quick look at our replacement diodes. So these also are from Maniac Electric Motors, and just some scribble here just to show you the location of where they're going to be going. They're marked positive and negative. The red ones will be positive and the black ones will be negative. And here's the part specs for their catalog. And even though it specs out 35 amp, apparently what's meant by that is each diode is not going to be responsible for any more than 35 amps per diode, so this won't be overloaded even on a 55 amp alternator. And I found a real nice article I'm going to place in the video description down below. It really talks about these diodes by somebody who's very professional and much more knowledgeable about them than I am, so you can check that out if you have questions on the diodes. And then also I was able to locate a replacement ID tag because this particular unit didn't have the ID tag on it. Somehow it had lost its way. Anyways, we've got a new reproduction ID tag. We'll rivet that back in place. Let's take a look at our refreshed hardware. So I re-zinc plated some of the hardware here just to freshen it back up. Also re-blackened our screws and oiled them. And then also new washers, lock washers, and nuts for our terminals. So just looking at how we're pressing out the old diodes, I'm just setting them up in a bench and using a couple of different size sockets. Press those out. Real simple to do. And just gently press them out a little bit at a time. And there's your diode. And then using some different size sockets for our positive side, let's do the same thing. Gently press it out. There it is. Okay, so that was simple enough to do. So we got our old diodes out. So now I'm going to press the new diodes in using the same method in reverse. I'm going to cut these old leads off, strip the old casing off of there, and put some new shrink tubing on there just to make it a little bit more supple. The reason I'm going to reuse those is I know everything is the correct gauge. So let me get that done and we'll take a look at it. Alright, let's have a look at our brushes here. So not too bad really. We got probably another 10,000-15,000 miles on those before we start having any kind of issues with them. But new brushes, easy enough to switch out, so we'll just put these old springs back in and resolder. And a little Loctite on our screws. Alright, well that's definitely not going anywhere. And being careful not to over tighten because we don't want to crush the insulators. Okay, and then our tension springs go down in the bottom. And then making sure our orientation is correct. I've already kind of done a dry run on that. Let's just take a quick look at our rectifier assembly. So I folded over these leads and cut them and then soldered into position. Some shrink tubing. I put a little bit of flux on the ends of these. They're going to go into these positions here, here, and here. And our other leads will fold over these tabs. These will also be soldered in place. So that's the positioning. Now let's go ahead and solder. And then I'm just oiling the ends here just to help run them in. Got a long thread to go. Well, she's starting to look like an alternator again. Nothing rubbing, spinning free as can be. And there's our finished product. Okay, so we're getting ready to give it a bench test here and see if she'll actually produce some electricity for us. So here is the basic wiring schematic. You can pause that. And this is for early 9/11. And then just a brief look here at my Frankenstein setup. So I've got a fan blowing on the front side of our alternator just for cooling there. We don't want to get it too hot while we're testing. Using a drill that's only going to produce so many RPMs for us, but it should give us some kind of a reading whether it's putting out any juice or not. Then I've got a power lead coming off the positive side of our rectifier going back into the positive side of the battery, and I'm pulling one lead off of that into a dummy ignition switch to go into our voltage regulator, which is also early 9/11, and also I can see if that's going to work, and then that's running right into the back of our alternator. Also, I've got a multimeter hooked up, so we'll be able to see exactly what's going on the second we spin it. And then I just want to show you this one thing. So I turn on the ignition switch, which is going to start an electrical field going. You can see it's really holding on to that socket. All right, we're not even spinning yet. Watch what happens when I turn it off. Okay, here we go. All right, we definitely got us an alternator. Well, that's going to do it for this one, guys. I want to give out a really big thanks to everyone at Maniac Electric Motors for making this possible. Thanks for watching, and we'll see you next time.